time transformation model. First, let us open the steady state CFX file. We shall save the steady state case as transient time transformation model. In the analysis type, we shall change the option to transient blade row. Click OK. Next, you have to change the rotor to stator interface as transient blade row model. Choose transient rotor stator. Click OK. Scroll down to transient blade row models. In this transient blade row models, you can change the option to time transformation. New time transformation and click OK. Here we can see the rotor passing period calculated automatically based on the RPM value which we have specified. The passing period is 0.000125 seconds. This is for single rotor passing period. We shall specify 2 periods for this whole run. And in the time steps per period, we shall give 10 time steps. Now click OK. It is showing warning that the number of time steps per period to be larger than 14. So we shall change the number of time steps per period as more than 14. We shall keep it as 15. Click OK. As per the next error, only point locators are supported when used with time transformation disturbances. So we shall go to output control and then remove the monitor points. Right click, delete. Now all the error messages are cleared. Note that you have to specify the number of blades in the whole domain in this R1 domain passage details. Here it is 30 for rotor, and similarly for stator it should be 45. Note that in transient blade row models, if we choose profile transformation, this is exactly similar to the earlier transient analysis which we did. Here the passing period and time steps are automatically calculated. However, to have the pitch ratio close to 1, we have to duplicate the number of rotor blades and stator blades accordingly. So we shall go back to time transformation. We shall leave the values as default. Click OK. Now we can save the case file and export the definition file. You can ignore this warning. This is for initial condition. We can specify the initial condition in Solver Manager. Steady state result file shall be given as the initial file in Solver Manager. Now let us open Solver Manager. Click New. Load the solver input file. Specify the initial value result file. You can choose the steady state file as the initial case for this. We can specify the run mode as parallel and start the analysis. Now the solver has started. The solver has completed. We can see the convergence here. Now we shall post process the results. Let us open post processor and load the transient results. Go to turbo mode, initialize all components, click calculate velocity components, outline, create turbo surface, click apply. You can change the color. We can duplicate the number of blades. Similar to previous case, we can choose the time step selector and find the flow pattern at each and every time step. We can export the animation using this animation option. You can save the movie and change the resolution settings here.